Watch this. In this edition, static precautions, opening the Pi, connections, booting, flashing the OS. This is static electricity, potentially hundreds of volts. It's caused by friction and is the same thing that's generated when you take off a man-made t-shirt and you feel your hair frizz out. You may even hear little discharge clicks or see small blue flashes in the dark. It's a smaller version of lightning, which can be a killer. These charges also kill electronic circuits. The Raspberry Pi is only designed to run on 5 volts, and this is why it's supplied in a protective bag as a protection against static discharge. We're not supplied with any special straps to remove static that will be used during manufacture, so as a precaution, touch a bare metal water pipe, a tap, or the metal case of a PC to discharge yourself before touching any bare electronic equipment. And even then, only hold the board by the edges, don't touch any of the components, and you will avoid killing the circuitry. So here is the Raspberry Pi, the revolutionary credit card sized computer at a small change price. Just have a look at this splendid design. This is the slightly more expensive Model B. The first thing you may notice is that most of the space is taken up by relatively large connectors, and not the components that actually do the work. The work is done here. This is the main chip. It's the ARM11 processor and is usually found in mobile phones. It's high-tech, but it comes at a low price because so many are produced. The other black device is the LAN controller. This is used to connect to the internet and is not included in the cheaper A models. We will cover all of this in far more detail in a later video. As we're keen to get this running, we will just concentrate on the connectors we are going to use for the moment. Here we have 2 USB ports. Connect a mouse to one and the keyboard to the other. Next is the LAN port. Connect this to your network using the standard RJ45 lead. The small connector here is for power. The single 5V supply enters via a micro USB connector, the sort that's now becoming standard with mobile phones. Audio, sound, is supplied by this 3.5mm socket that connects to conventional PC speakers. Alternatively, you can rely on the audio in the HDMI video picture output. Connect this output directly to an HDMI screen. Now notice here that we have what is the best quality video standard available today, HD, high definition. There is no port available that will connect to a conventional PC screen, using this style of 15-pin D-type connector. It and the standard it uses are not supported, as it's going out of fashion. You can, however, connect to a DVI-V port using a cable or connector. Most domestic flat screen televisions will have an HDMI port. If all this fails, video can be connected using the final port, the connection for what is known as baseband video. This uses the familiar style of RCA phono connector and is typically yellow. You can still see these connectors on TVs, cameras and set-top boxes, normally with the separate red and white audio options. You can use the yellow video connector, but it's analog, not the better quality digital as provided by HDMI. So, insert the connectors, add the power and nothing. But don't panic, it's not broken. It's just the Pi does not know what to do. It has no instructions. The instructions are contained in the final component, the SD or SDHC card. If you have one, remove the power from the Pi, insert it and restart. Loaded correctly, the Pi now knows what to do and follows a process known as booting. Booting or bootstrapping comes from the rather crazy notion that if you pull hard enough on your own bootstraps, you can lift yourself up. Try it. Add a few instructions to learn, use these instructions to learn more, and before you know it, you're flying. Let's put it another way. The Pi, when it's first switched on, is like a newborn baby. It knows nothing but to look in one place for pointers as to where to go. In the same way, a baby just looks for its mother and food. This is the critical stuff at birth. It can learn to ride a bike and use a parachute later. Feeding is all it needs to do initially. All the Pi needs to do is look for the SD card and follow the first pointers. These lead to further instructions that help it to know about the card, the other devices on the board, and loads the rest of the system. With these loaded, it can load yet more instructions. Every computer does this at startup, learning about the attached devices, learning routines, and loading drivers. But what to boot? The booting process on the SD card teaches the Pi how to operate. This is why, once completed, the Pi is running what is known as the operating system. Without the operating system, programs, applications, or apps can't run. So where did this operating system come from? Well, there are several options. You could have purchased a pre-programmed SD card with the Pi, or you could have made your own copy. Buying one is simple and quick. All of the work is done for you, and with luck you should just be able to plug it in and away you go. But that's not the spirit of these videos. Here we grow by learning to do things for ourselves. After all, once you know, you have the power, and you can pass this intelligence on to others. After all, it's not really that difficult. The process of copying an operating system to the SD card is known as flashing the OS. Although when you see how long it takes, you may realise that flashing does not relate to the overall speed of the process. Other than the power of just knowing how to flash the OS, there are a couple of good reasons why you should learn this process. The first is that you may break or brick the OS when it's in your machine. It's always comforting to know that you know how to remove the card and reset it. The second is that this course will compare several different operating systems. It's good to change these quickly and understand what you're doing. You will see that different operating systems appear to change the personality of the machine. Finally, all operating systems have bugs that need to be removed and improvements that need to be updated, including security patches. Again, it's good to be confident to know how to fetch the latest version and install it into your machine, and keep it up to date. So, to flash an OS, you first need to know where to find a reliable version, how to download it, how to prepare it, and finally, how to flash it onto a card. Of course, the reliable version is always available at the source, raspberrypi.org. Files on this site, or sites they point to, are genuine. It's also always a great source of useful data and up-to-the-minute news. If you understand compression schemes and torrents, then continue. Otherwise, skip this whole process and use our local direct downloads. It will take longer, but it works. Log into your Moodle course and click on the links Latest Fedora IMG and save. Repeat with the latest Debian.img. Make a note of where you have saved these massive files. They are likely to take some time to download, but at this stage the delay is likely to be worth it. Debian and Fedora are names of two different versions of Linux. They are what is called distributions. There are hundreds of distributions, each slightly different, but these two are very popular. They are the personalities given to the Pi mentioned earlier. You may have heard of another, Ubuntu, which has not been ported to work on the Pi as yet. This is being worked on, but is another reason why you need to learn this flashing process. We will of course cover Linux in much more detail later. To return to the latest Fedora.img and latest Debian.img just downloaded. These two files are known as images, hence the .img extension. Unlike copying music or a file, the image needs to be placed exactly in the right place on the SD card. Otherwise, the pointers we referred to in the booting process will not pick up the correct starting instructions. We now need a program that will take these images and place them exactly in the right place on the SD card. A link to a free copy of Win32 Disk Imager is available in Moodle. In Windows, click on the link and follow the installation instructions. Running the program should be fairly simple. Place the SD card in your card reader. Disk Imager should recognise the new card and allocate it a drive letter. Here it is drive O. Select the image to be written in the pull-down and press Write. Confirmation of a satisfactory copy should be shown at the end of the copying process. This may take several minutes. Eject and remove the card. Insert the card into the Pi and turn on the power. After a few moments, evidence of the booting process should be seen on the screen. The personality difference between Debian and Fedora will be seen during the initial booting process. Both will start, configure, and then reboot before coming back with a prompt. We will leave this at this point and return in the next video. We've covered a good deal of ground in this video, understanding static and how to prevent damage to the Pi or any exposed electronic circuit, identifying the components on the motherboard, connecting the Pi, knowing the boot, knowing where to get the operating system, and flashing the operating system.